Hey guys, this is Chen. Today is our Rasch section 2. So today the purpose of this R Rasch section is to help you to practicing evaluating the model data fit with the transitive reasoning data from the previous lab. So today we are going to use the ERM package. It's a little bit different with the TAM package that we used for the last week. So for the ERM package, they use the CML, which is the conditional maximum likelihood, instead of the TAM. They use the MML, which is the marginal maximum likelihood estimation. So when you try to compare like the two different results, you will find like the parameter estimates a little bit different. But however, like the orders of the Rasch logics supposed to be pretty much the same. Before we go into the class, let's prepare. We always prepare the package first. And if you, I don't know whether you are like, maybe you are a first time R user, so please note when you use your use the Rasch R Book, all these codes are like, I expect you that you have already installed all the packages on your console. So if you don't have any experiences, so you might need to install the package. Install the package ERM. So whenever you see there is a library something and you might have some error code saying that you don't have such package, just using this code. So you can put whatever the package's name here. Don't forget the quotation mark, and then hit the run code. Hit the run button in here, so you can install the package. Since I've already got the package on my console, so I'm just gonna skip that part. And then let's load our package before we go. Then we load the same package same data set that we used for the previous data. You see, in here you have like your global environment, so it might have something that you run for your other assignments, or like you have like abundant redundant file that maybe you run from the last time, so you can always clean objects from the workspace like that, and you hit yes. So now it's clean. So let's do that again. Now you only have, you can preview your data here. So if you are a first time R user, so this is like a kind of neat way in R Studio to preview your data. You can just click your data here, and then you can have a preview of your data matrix. So in here we can see this data contains 12 in here, 12 of 425 entries, so 12 columns. Here is 425 observations. So in here we can see for each observation, so that's a student. This is the first column is the student ID, the second column is student grade, and then we have task 1 to task 10. Also, there is another neat, you can always sort it by there. So you can in here, so you can see the minimum is ID student ID 1, and the maximum is 425. Also, you can see the grade. You can see all the students are from the grade 2 to grade 6, right? So they are students from grade 2 to grade 6. And then when you check each tasks, pretty much they are all like dichotomous binary coded. So it's either 1 or 0. And there's another neat way to preview your data in here is when you click that filter. So you can basically you can see there is a matrix, there is a distribution chart for you to see. So let's say in here you can see the students are like evenly, almost evenly distributed from to each grade, right? And for the task, you can see like for task 1, most of the students got corrected answers. So in 1, it's like really such long bar in here, but 0, like it's really a little less people in here. And for task 2, task 3, so you can always check these. Also, if you just want to see that like in a numerical style, so you can use the code summary your data. So you can see a summary table in here, so give you some the most important thing in here to use the summary function actually is to see whether there is an NA, which is the missing value, because sometimes missing values do influence a lot to your result. So following sections, Dr. Wind will have a really deeper discussion with you on how to dealing with these missing values. So, but like in here, you might check whether there is a missing value in your data set. And then you can see the minimum and the mean and maximums. So actually from here, when you see all these means, you can almost tell like the difficulty level of this item, right? So for items like relatively easy to answer, this item should have a higher mean value. So for task 1, so it's not a very hard item, I guess, because 94% of students got these items correct, right? And then we have 80 here, 88, 78, 78, 18, 80. So when you check these data in here, you pretty much can tell task 6. Task 6 might be like the easiest task because it has the higher risk mean. And let's see, task 9 should be the hardest task because it has the lower risk mean. Okay, so we will prove that in our Rasch results. So let's trim the data first. So similar to the TAM package, we only need the response to run the dichotomous Rasch model with the ERM package. So what is the response matrix? So when you check your data in here, you just click the table icon in here. So when you check your data, you can see the response matrix only contains task 1 through task 10. So we don't need student's grade and the student's ID. So they are unrelated information for running your Rasch model. Okay, so the first step, we are going to trim the data first. So we use this code to trim our data. All these codes you can find on your Rasch book, and you can always copy and paste from your Rasch book. And also, if you're a first-time user, so you might not really understand why we are using this code and how to like make some changes to the code to like fit your own data situations. So that's okay. We can set up time and make a point. You can make an appointment with me online, and I will help you to have a basic understanding on what is R and what is R coding. So don't be hesitated to contact me if you have any questions concerning using R. Because in here, I think a lot of you from the class have a basic R experiences. So, but if you never touched R, it's okay. So just set up time with me, and it might take a little, like 30 minutes to an hour, so I can introduce some basic techniques of R to you, and from that time, so you can like starting with running all the Rasch models using R. It's a neat skill. Okay, so we use the hand function to take a preview of your data. Here, the hand shows you, if you don't specify any number in here, the hand function always display like the first 6 rows, but also let's say if you want to take a look of 10 observations, so you just put in 10 in here and hit run. Now you can have like 10 rows, and since we already trimmed our dataset, so now the dataset only contains task 1 to task 10. Okay, so now let's going to run the Rasch dichotomous model. So running Rasch dichotomous model in TAM package, in ERM package, is really simple. It's just RM. Stands for Rasch model. So I saved your the model results in Rasch model in here. So let's check the summary of that model outcomes. Basically, you got some critical information, such as your conditional look likelihood, such as your iterations, your parameters, and in here you can have a beta parameters, but it's a little bit different with your TAM results, because in here take closely look. This is item easiness. So, but in the previous lab, we are talking about the item difficulty. Okay, so this pretty much are the same number, but with different opposite direction. So to get the item difficulty, what we do is this code is for you to take out the beta parameters, just in here, just the numbers, these values in here, and we multiply it by -1, so then we can have from item easiness to item difficulty. Okay, since like among the most of the Rasch studies, like we are more people are more you get used to report the item difficulty instead of item easiness. And then you can have your item difficulty in here. So let's say I want to see what is the most difficult item and what is the easiest item. So in here it gives you the idea if you summary your item difficulty. So your minimum is -2.17, which is task 6. And then your maximum is 2.92, which is in here. So as we stated in the previous lab, if this is the logit scale, right? So the higher on the logit scale means the item is more difficulty. The item is actually harder. So we can tell in here from our summary, we can tell the task 9 is the hardest item, whereas task 6 is the easiest item, right? And we can also look at the standard arrows for the item location. This is the code for you to take out the standard arrows from these betas. Let's run the code. Hit run. And then we can still use the summary because these are a bunch of values. We want to see what is the maximum and what is the minimum. So in here, minimum is 0.11 and the maximum is 0.29. But since the mean is 0.16, is like 0.17, so it's a decent standard error. Okay, then we are going to do the model data fit. So the model data fit in the context of Rasch model is different from other IRT models. Other IRT approaches focusing on finding the best model to fit the data. However, the Rasch approach focusing on diagnosing departures from model expectations. Within the Rasch framework, the model is viewed as an ideal type. It is a theoretical mathematical description of what measurement looks like. Its fit statistics summarizes discrepancies between observations and expectations to help researchers improve their measurement procedures. So in here, your model is already an ideal model. So in the process, our model data fit, we are trying to looking for, okay, what's wrong with the item and what's wrong with your student. Maybe the text takers are not your target population, or maybe like your design, your test design, item design is really not really good. So in here, when we are running our Rasch model, like the results will give us some directions to see whether what's wrong going with my test takers, participants, or my item designs. So first of all, we are going to I put the reliability of the person separations from equation in here, so you can go over your lectures by reviewing these equations. But in here, the ERM package already provides you a function to calculate the person separation. Okay, reliability. So this function calculates the proportion of the person variance that is not due to error. The concept of the person separation reliability is very similar to the reliability in indices such as the Cronbach's alpha. Okay, so let's run that. Since we already got our dichotomous Rasch model result, so we need to use the person parameter function to take out the person parameters and store that in here. So when you run the coding here, I hit the command plus enter in here. So basically it's the same thing when you click the run button in here. Okay, so now you should have your person parameter, and this is a list of 18 different items. And there are only several things like we need to focusing on. In here, we are looking for the beta, theta, and the standard errors of theta, right? Let's do the summary on that. So now it shows you the separation reliability is 0.4445. So it is at an acceptable level. And also it gives you the observed variance and the mean square measurement error in here. And then let's do some plot. We start with the plot item information curve, which is the IIC. So let's run that. Now you can have your item information in here. Since this chart is not shows you the pictures really good, let's okay, so if you export your the charts, you will have something like that. And this is a bug. On your right side is supposed to shows you different lines align with the different item numbers. to shows you like what color stands for what item. But in here, for some bug issues, if you have more items, in our case it's 10, so if you have like that many items, it cannot display properly. However, you still can tell, like we almost can tell like which, because in here this is the logic scale, which stands for from easy to hard. So if like the mean in here, the top point in here indicates the location of that item, which is the item easiness. So we can tell from our previous result in here, item difficulty in here. So let's check the item difficulty. So pretty much the negative item 6 is the easiest one. So -2. So this is, see, -216. So this is -216, and the second one is the red. The red line is the next one, is the -1.9. So this is the item 1.9. This is the item 8. So basically, it shows you all the items ordered from negative to the positive. And when you like trying to mean all these, take the mean of these, so you got your test information. So basically we can tell our test is like normal distributed, and it's amount 0, like the mean is really close to 0. So which means our test is a decent test. And then we are going to the most I think the most critical parameters, the part of our model data fit section, which is the infit and outfit. Here, some students told me like they have like really had some hard time to remember, to distinguish like what is the infit and what is the outfit. So in here I can share you a little bit tips for you to distinguish like what is the infit and what is the outfit. For outfit, mostly is something out of the box, out of the expectation. So it's gonna be huge, which means when the outfit is abbreviated from 1, maybe it's like 2, 3. So which means some smart people doing a really dumb things, like really a student with a really high ability and get a really easy item wrong. So this happens, right? This happens because sometimes it's just careless, right? It happens. But the infit is something inside the box, is something reasonable, such as a student has a little bit higher ability, but did the item wrong with a little bit less requirement. So if, let's say, on at the same logic scale, a student is like 1, but the item is 0.95, it's really close, right? And the student is supposed to answer the item correct because his ability is higher on the logic scale than that item. But mistakenly, he got this item wrong. We don't know why, but if that happens a lot, your infit will be a trouble. Your infit will be abbreviated from 1 way from the 1, right? So for me to remember that is just think outside of the box and think in the box. If it's like both infit and outfit, that's a mistake. Shows you how mistakes those your participants answering these items. but the outfit means the huge mistake. You should never get these items wrong, but the infit shows you a little mistake, right? Your level is supposed to be higher than the item, but you didn't make the item correct. So that's the only differences. Okay, so now we are trying to calculate the item fit statistics using the item fit function. Since we have already the person palm, so we use the item fit function to calculate the item fit, and then we store that in a die item fit. So let's take a look at our die item fit. Now you can see we have all the p-values, dfs, and we remember we have 425, right? We have 425 observations. Why our df is 373? I give you 5 seconds to think about that. 5, 4, 3, 2, 1. Okay, the correct answer is when the Rasch model is like running when this function is running the Rasch models, it kick out some observations that not meet the requirement. So for those test takers, if they have only used the one categories, let's say if if a student 16 got all the items correct, and then there might be another student got all the, like here it's not all, but it might have someone to got all the items wrong. What it means if you got all the items wrong? So that means like your ability is unmeasurable, right? You cannot say that like the task might be too hard for you, because if to get something wrong, if you don't answer anything, you will get all your items wrong. So we cannot tell what happened exactly. So for these kind of data, the system will kick them out automatically. So you don't have to worry about that. We want to measure is the expected answers. And also, if a student got all the items correct, that's also a problem, right? That means the student might be a little bit higher than the overall test on the logic skill. In another thought, like the student might be higher than, let's say, like if you are a PhD student and they gave you something from the elementary school, grade 1, it should be like super easy for you to answer these items correct, but they cannot tell like, okay, your ability is just above the grade 1 a little bit, right? And then we have our infit and outfit. So these two columns are like the most important columns. So these tables will give you the information about infit and the outfit statistics for each items. So noting that we generally expect this statistic to be around 1. If you cannot tell like what is close to 1 and what is not close to 1, like an easier way to here is to just see the p-value. If the p-value less than 0.5, there might be something wrong with your item. Or if p-value is like 1, it also means something wrong. Okay, now let's calculate the person fit statistics. We got the item fit, then we store the person fit in here in our in the person fit. Since person fit is a long list, let's take a look with 374 students. So I'm not going to print out a really long list to take a close look on how, like, which student has like the, we can just use the summary to see their infit and outfit. So in here for the infit, for the person infit, we can see the minimum is 0.4 and the maximum is 2.24. And in here for the person, the outfit, the minimum is 0.17, the maximum is 0.7.3. So you can tell like those students might have something wrong because their infit and outfit value are far away than 1, right? So we can see that there is some variabilities in person fit, with infit MSE statistics ranging from 0.41 to 2.25. And outfit MSE ranging from 0.17 to 0.7.3. But another thing is, so these are the outliers. So it's common for them to have extreme values. Otherwise, we can call them outliers. So, but like, we trying to understand whether these peoples generally has like a close to 1 index. So in here we can see the median and the mean. So in here for the infit, they are kind of close to 1, which is good. And for the outfit, it's the mean is a little bit close to 1, but like the median is kind of worse. And then we can use the person misfit, this item, this function, to find those people who misfit. So let's use this function in here. Choose the function and hit the run button. Okay. So this function counts the number of the persons who do not fit the Rasch model. More specifically, it returns the proportion and the frequency of persons, or more generally cases, who exceed a chi-square base z values of 1.96. So this is a statistically significant situation, right? So it will report the person's numbers who not fit the Rasch model. In here, you can tell there are 6 people. So the detailed numbers for the misfitting is 6. So this is the number of the person for whom a fit value was estimated. Also, when you just print out the misfit person, it will give you the percentage of misfitting persons. So you have 425 persons with 1.6%. So you have 6 persons. Then we go. Now we are going to plot some map to see whether we can catch those outliers. So first of all, we can plot the item map. This function is called the plot PW map. Actually, PW stands for the pathway. So this is a Bound and Fox pathway map. Bound and Fox is the 2 authors write your textbook. So a Bound and Fox pathway displays the location of each items or each person's against its infit t statistics. So let's just print out the map so you can see in here. So on your left side, this is the logistic scale, and on your right side, this is the t statistics. So the t statistics shows you how abbreviate your infit for these tasks. So you can see in here, so most tasks are kind of common because they are inside -2 to 2. 4 tasks has some problems with their infit. So there are task 10, task 7, task 3, and task 4. So when these tasks have infit problems, infit warnings, that means so some students who are like little bit lower than these items might have a correct answer, or students who have like a little bit higher ability than these items might have wrong answers. We can also plot the person map if we say p map equals to true. So in here we can see we probably can find our outliers here. So these are the, if you see P12102, is that P46, P361. So basically we have, I think there are 6 persons in here. Our 6 outliers are all in here. Also, we can construct a plot that shows item and item locations in the same graphic display. And then I'm going to show you another plot, which is the PI plot, is the person item plot. Here is the person item plot. So this plot is different with the previous one. Is this one on the person side, it shows you a distribution, and on the task side it put like the y-axis to the x-axis, and it listed all the persons and the person distributions and the tasks on the left. So you can tell like an order from the easiest task to the hardest task. And also when you check the distributions, you can see like the most students, like their abilities around 1 to 2, right? And also when you check the person item map, you can see there's some of the students location way lower locations comparing to all the test items. And then we are going to have a brief introduction on our task characteristics items, which is the ICC. So you can just simply use the plot ICC function. And in here, if you don't know like what is the argument means and what is the ask means, a simple way to do that is always a question mark, then the plot ICC, copy and paste, and then you should have a detailed introduction on like what is the plot ICC function. This is the plot ICC function, and this is the object you're supposed to put, and how many different arguments that you can use. So for these arguments, it gives you a really detailed information on like how many settings you can have on your function. So ask here is false. Ask if true, and the ask action is interactive. The user is asked for input. So I just want the console print out all the ICC at the same time. So that's why I selected the false. So when I hit the code, it's gonna automatically give me all the plots. Okay, so let's go to see these beautiful plots. So this plot shows you the items on the latent dimension, which is the logit scale, and this is the probability that your test takers got these items correct. So in here, basically for each plot, we are trying to looking for the 0.5 on here. So 0.5 is almost, it's like close to 0 in here, which means this task is okay. So let's go to the task 6, which is the easiest one, so it should have some problem. Task 6, you see, and task 6 in here, if you do like 0.5 in here, it's -2, which means a person has like a -2 legit abilities, so has a 50% to get the items correct. So when it's 0, when it's almost everyone can almost, it's like really high. I think it's 0.7, 0.8. It's like all the peoples, it's almost all the peoples can get this correct, these items correct, right? And when you check here, if you check like 0.5, it's almost 1. If you have like a legit, if you have your ability on legit skills around 3, I guess 1.5 at least, a 2.5 at least, then you might have this, might answer these items correct. So basically from this, we are looking for some plots like this. So item 7 is kind of like a model item, so we are expected like the most of our items can have that kind of shapes. And item 5 is also great. Then let's plot the standardized residuals. For plot out the standardized residuals, we need to take out the standardized residuals values from the item fit. And then before we construct the plots, we need to find the maximum and the minimum residuals. So we got the ceiling max and the ceiling minimum. Then we use this code, and thank you, Dr. Wayne, to sharing this wonderful code to us. So for using this code, we can plot the standardized residual plots. So basically, if you are going to use your own dataset and running your own models, all you have to do is make sure these item numbers and the standardized residuals, like using the same variable names. If you are using the same variable names, you won't have any troubles. You can almost using the same code to run your own results. Okay, so let's run the code, and then we have a bunch of plots from item 1 to item 10. So this plot helps you to locate the outliers. And in here we have person, this is the person index on the Excel. For all these plots, you are looking for like the plots, all the points are really close to that this red line, the blue, really close to that blue line. This is the expected line, so we hope all our test takers are close to this expected lines. So any ones are out, like really abbreviate from this blue lines, and out of the red, negative and positive 2 standard deviations. So these might be outliers for this specific item. So we hope we expected these points, abbreviate endpoints, like as less as better. So you can check. Item 3 is okay, you have several but not too much. And item 4 is not really okay, because item 4 has more outliers in here, and item 5 is pretty much the same. Item 5 has less abbreviate, less outliers, I guess. Actually, item 6 is kind of acceptable because this is the easiest item. Okay, then we are going to plot the item characteristics curves, which is the IRF. This is the IRF plots code. Then we should have IRF. So in here, since I also print out the empirical ICC, so you see like the red dots. So these are the actually points, and this curve actually is the estimated curve based on these observations. Because based on these different locations of these observations, we try to get like a perfect curves to answering to describing how these items functions. So sometimes you can tell like the curve is really close to that. Okay, so that's pretty much everything for today's section, and also I provide you some learning materials at the bottom of your Rasch book. You can just simply click that link to achieve that. Let me get that. So you can scroll down to the end and just click the link. Click the link, so it will give you more explanations on what is the infit and what is the outfit, and also it shows you some examples on the different estimation methods. And I think this is the original paper on showing you how to compute the outfit and infit. So if you need more information, and if you want to have a deep discussion on applying all these models, so don't hesitate to show me an email, and we can set up time, have an online Zoom help session, our help session with you. I can set up a specific time with you to settle down if you have any questions regarding running Rasch models with R. Okay, so thank you for the watching. Here's all the courses for today. Thank you for listening. Bye bye.